phone and asking you to retake. It was quite interesting, but it was a very long day, and we're doing it again tomorrow. So fun. Hey Jeff, how's it going?
Good. I'm staying dry here. You know, we had a big storm yesterday come through Auburn. In fact, probably an eighth of the B Lab roof's protection, like metal sheeting, came off. So yeah, I think facilities is over there fixing it right now. I was a little disappointed. I was hoping for a bigger storm, and then we get a brand new building like Jamie's got. But I guess we'll just have to wait and see how that goes. But in fact, I also had to make an emergency trip to Dr. Saruda's or in her direction on Monday because one of my students is doing a project looking at the effects of pesticides and mites on drones. And well, you know, whenever you need mites, you can never find them. So we had to exchange mites in a Kroger, or no, what was that? I forgot the name. Maybe Jennifer's on here. Where did we the Kroger parking lot?
Panera.
Of course, we were physically. Oh yeah, Panera. We had
I
to
had to
physically
get
distance
cookies.
wearing our masks, but she managed to hook us up. So I know Selena, my doctoral student, is really happy by that. So thanks Jennifer for that. So yeah, that was quite an adventure. I haven't left the Auburn bubble in probably 2 months, so it was a little bit refreshing to see some scenery. But I'm back here, hunkered down in Auburn now. So yeah. So I've got a question. I see everyone's writing in the chat where they're from, and I've been kind of monitoring, and I see there's someone as far away as Slovakia and Hawaii. So we've got basically like half the world covered there. Um, Here in Auburn, we have a lot of things blooming. One of my students is also looking at native wildflowers. So I've stolen some of his seeds and planted them in my backyard last year, and I've got all kinds of things blooming like blanket flower and cone flowers, and we got some bee bombs popping up. So maybe everyone can type in what they're seeing in their area and like what's their favorite flower that they're seeing right now in the chat box. And if you can, punch in some native wildflowers that you love seeing every spring or maybe in the summertime, particularly when the bees are looking for stuff. I've got some mountain mint too. It smells very nice.
I just planted some Phacelia seeds. Well, it's just now starting to bloom. I planted it a month or two ago. And I'm really interested to see how the bees like it. I've heard that they really like it. So I think it's commonly called scorpion weed.
We had to plant some of that 2 years ago for one of our students looking at I guess the forage of small hive beetles, but we had to have these little tents and we planted Phacelia in there for the Osmia species. But I know yeah, the bees are all over that, and they actually use that for a lot of risk assessment studies as well, Phacelia, because they know it's a very bee attractive crop. So they'll yeah, apply their insecticides, for example, and see how that influences bee colonies, for example. Someone's asking Allison if you planted your sesame.
I planted, that's John, he gave me sesame. I planted part of it, like part of the packet, and it didn't take the first time. I'm going to do it again in the next couple of days.
So
Wow, Peggy,
I
where is
did.
Peggy? Macadamia nut. Wow.
I think she's in Hawaii. And I did catch
Hawaii,
last or
probably.
2 weeks ago the talk by Dr. Delaplane, and you guys were talking about the worst places to be stung. Well, in fact, we've got a new faculty member at Auburn. His name is Michael Smith, and he's the one that he did one of these studies and tested all over his body where the most painful location is. And as you can imagine, yeah, where that position is. So maybe I can twist his arm in the future. He can come give us all a talk of the stay-at-home beekeeping series. He's been here for a couple weeks now. He was in Germany before, so we're really happy to have him around.
Um, I've always thought of maybe doing the same study, but on a woman, a female subject. I've thought about it. I mean, considered it, like maybe, but they say women are more tolerant to pain, so I don't know. And definitely female beekeepers are, right? We can take the stings. Ooh, under the fingernail. Yes, that hurts.
I'm gonna see if I can Google his paper and put it up there. Yeah, it should be open access. It's called the Honeybee Sting Pain Index by Body Location, and he's got a nice drawing of a hypothetical human being. So I'm going to post that in our little chat box here, so everyone can take a peek at that when they get a chance.
So here in, I guess the Brazos Valley, Southeast Texas, it's supposed to be the great season of nectar flow, and we've been struggling, or the bees have been. There has been no flow. Maybe right now it's starting out with a little bit of horse mint and thistle and wildflower, but we've been feeding our bees, and that's typically not normal, although nothing is really normal in this part of Texas in terms of weather. But I wonder if some people have suffered similar situations with no flow coming this spring, or as early as it usually does.
Yeah, at least in Auburn, we've kind of noticed that. I think talking to some of the students today, it seems like it's picking up now, but yeah, I thought that early cool spring might have done us well with all the clovers, but doesn't seem to be working too well. And well, we've got Chinese tallow that's just ready to pop, so we'll see how that does for us.
Actually, drawing to the close of tallow tree bloom down here.
Okay.
So things
How are
are
your
still
colonies
pretty light
then?
in the hive.
I'm
sorry?
All right, everybody, it is 6:30, which means it's time for us to start. We thank you all for joining us for our stay-at-home beekeeping series. We hope you're all doing well and safe at home. This series is brought to you by the Alabama Cooperative Extension System, the Auburn University College of Ag, the Auburn University Bee Lab, with cooperation from universities and extension systems from the University of Florida, University of Tennessee, Knoxville, University of Georgia, and Texas A&M University. My name is Allison Chable. I'm an urban regional extension agent for the Alabama Cooperative Extension System. I'm on the beekeeping team. We have 3 co-hosts this evening. Dr. Jeff Williams is the assistant professor in the Auburn University College of Ag. Jack Rowe is the beekeeping specialist with Alabama Extension. And Dr. Juliana Rangel is associate professor of apiculture at Texas A&M University. Our co-host tonight will be monitoring the chat box, so if you have questions, please type them in and we'll do our best to get them answered for you. To find the chat box, if you look at the bottom of your screen, there's a little chat bubble, and if you click on that, it'll bring up the chat box. So type your questions in there, and if you're on the Facebook live stream, welcome. You can type your questions into the comments sections, and Jack and Dr. Williams will help get those answered for you. We would like to know a little bit about you tonight. So I'm going to put up a poll so you can tell us a little bit about yourself and your apiary. This will help us kind of know where to go with this series in the future. Now, if you want to go back and review this session or the last session, Dr. Delaplane's, we keep them on the Lawrence County, Alabama Extension Office Facebook page for 2 weeks only. So you've got about 24 more hours before we take Dr. Delaplane's down, and Dr. Ellis's presentation will be there for 2 weeks. Tonight, our presenter is Dr. Jamie Ellis. Dr. Ellis is a Gahn endowed professor of entomology in the Department of Entomology and Nematology at the University of Florida. He has his Bachelor's of Science degree in biology from the University of Georgia and a PhD in entomology from Rhodes University in South Africa. At the University of Florida, Dr. Ellis has responsibilities in extension, instruction, and research. And regarding his extension work, Dr. Ellis created the University of Florida, South Florida, and Caribbean bee colleges and the University of Florida Master Beekeeper program. As an instructor, he supervises PhD and master students, and currently he and his team are working on over 30 active research projects in the field of honeybee husbandry, conservation, and ecology, and integrated crop pollination. Dr. Ellis, we're very glad to have you, and I'll let you take it away.
Great, Allison and all my co-hosts. Allison, give me a thumbs up if you can hear me. Perfect. So good. That's great news. So I'm going to get started because I know we have a lot to cover and I want to make sure we can get through all of it. First, I want to thank Auburn for arranging all of this and the collaborating institutions and all the hard work, though, especially Auburn has put into this, making it possible. I also want to thank you guys for attending. We have quite a few participants watching tonight. I'm grateful for that. I was scrolling through the chat box at the beginning, looking at some of the names, and I recognize some of your names. So it's cool to see some people with whom I'm familiar. And as you can probably tell, like the rest of you, we're all doing this from home. I am doing this from my home. In fact, I happen to be in my kids' playroom, and right on the other side of the door to my right, I've got my kids. Hopefully my wife is keeping them quiet, so everything's going well. We're also happen to be in Florida, and I'm sandwiched right now, but in a calm spot between two thunderstorms. So if for some reason we get cut off, I'm going to do my best to up very quickly. I know that my slides, Allison has a copy of, and I can call in using a phone if for some reason I lose power and Wi-Fi. So with all that background, I just want to say thank you again for joining us. And I'm going to talk tonight about what's killing honeybees. And you can see here on my opening slide, that's my name, Jamie Ellis. That's my email address. Feel free to email me if you have questions. I'll give you some contact information from my laboratory here at the end of this presentation. All right. And as Allison shared, I work at the entomology and nematology department at the University of Florida. All right. So let's kind of get started. And I tend to be a rapid fire person. I've done quite a few Zoom talks, so I'll do my best to keep you paying attention in the process. All right, I think we only have 20 some odd slides, but I want to show you some slides. I also want to get you on the internet in real time and show you how you can find some of these resources I'm mentioning. But first, we're starting here on this slide. You are looking at the Western honeybee. Now, there are 9 species of honeybees. Again, it depends on who you ask, but tonight I'm the expert, so I'm saying there's 9 species of honeybees. One of those occurs naturally outside of Asia, and that's this bee that you're looking at here. There are different types of Apis mellifera in Europe. There are different types of Apis mellifera in Africa, and there are different types of Apis mellifera in Western Asia, as well as in the Middle East. So we keep European honeybees, and they are just one type of Apis mellifera. I've actually been a beekeeper since I was 12, and so I started keeping bees exactly 30 years ago. So you can figure out how old I am if you just add those two numbers. And I've just really enjoyed keeping bees for quite a long time. I've enjoyed it. I love it. I have a couple bee colonies in my backyard still, just to remind me why I like bees, because it gets to be troubling a lot, because when they invite people to speak about bees, they almost always want us to talk about the problems and how to solve them. So that's really the theme of tonight's talk. What actually are the big stressors that honeybees face, and what can we as beekeepers do to address it? Now, I've only got 45 minutes before we get to the Q&A. So if I spend all of my time telling you what they are, you can probably appreciate we'll be able to spend very little time talking about how to address it. But that's why I wanted to be able to have some internet time with you tonight, so I can show you some good resources, so that after all this is done, you can have access to that information in my absence. So you ready? Let's get started. I am showing you now a chart that every bee scientist is either seen or created him or herself. This is a chart of the number of honey producing colonies in the United States of America. And you can actually create this chart yourself. There is a group called the National Agricultural Statistics Service, and the biz, we call it NASS. And if you Google NASS and your agricultural commodity of interest, NAS blueberries, NAS watermelons, NAS what have you, you will find the NAS report related to that agriculture commodity. And it will tell you how much of that commodity was produced by state, et cetera. And if you Google NAS honey, and if we have time, I'll show you this later today, but if you Google NAS honey, you'll get the honey report. And with that honey report, it tells you the number of honey producing colonies in the US. They've been keeping those data since the late 30s, I think 39, in fact. And the way NAS works is the current year report, the 2020 report, reports the previous year's data. So the 2020 report came out May 16th. So you are the first group of beekeepers I've shown the slide with that little point right there updated. So you're looking at the number of colonies we are said to have here in the United States. And again, that's according to NAS. So this seems important to us, right? Honeybee populations seem like they're declining. So let's think about this here. Using those same NAS reports right there, NAS 2020, this is hot off the press, you'll see that last year we produced 157 million pounds of honey in the US. For you non-Americans out there, that's about 72.5 million kgs. I had to do some extra work to make sure that both of those numbers were up there. And that amount of honey was produced by roughly 2.7 million colonies last year. And the value of honey in the US was about $309 million. That sounds like a lot of money. That's great for all you Floridians watching. Here's our share of it all. We have about 9.2 million pounds of honey produced, and the value of that's about $23 million. So if you've seen me give this talk, this is a talk I've been giving for a few years now. If you've seen me, you'll recognize that right about now, I tell people that as much as we like to eat that yummy bee vomit, it is not what drives the industry. Honey production is very important. That is undeniable. I like to put honey on biscuits as much as the next person does. But I will tell you what drives our industry really is pollination. All of you know this. You're beekeepers or aspiring beekeepers. So you know that the value of honeybees comes through their efforts as pollinators. You see, honeybees, and all bees for that matter, have an insatiable appetite for pollen. They go to flowers to collect it, and they bring it back to their hives where they store it in combs like what you see here. That's bee bread. And they will then mix that bee bread in with some of the food that they feed their young. The young adults will also eat the bee bread. And of course, you all know that pollen is the protein, vitamin, mineral, nutrient source that bees get. But you know, there's a catch-22. And the catch is this: even though the bees are benefiting from collecting pollen, the plants are also benefiting from collecting pollen. Because bees pollinate flowers or collect pollen from those flowers, we get fruits, vegetables, nuts, berries, all kinds of things. They're important for our food production. They're important for agriculture in general. They're important for ecosystem health. We know this. There are estimates that 10 to 20% of the world's food production is dependent on honeybees. You know, a lot of people will say a third. I tend to be quite conservative when we don't know for sure. And since we don't know for sure, I usually tell people about 20%. But even if it's 1 out of every 5 bites of food we eat, what other agriculture commodity can claim that? And every time I get to this point, I love to use the standard McDonald's cheeseburger to teach this point. Now, as much as you guys pretend you don't eat at McDonald's, I know better. We all secretly eat at McDonald's. And if you know the standard McDonald's cheeseburger, you know from north to south, it's a bun, pickles. Well, it's actually a bun, ketchup, mustard, pickles, onions, cheese, beef, and another bun. If I were to snap my fingers and take bees out of the picture, you would have the bun because it's from wheat, presumably, and grain crops are wind pollinated. But you wouldn't have the onions because onions are grown from seeds that had to be planted and ultimately pollinated by bees. You wouldn't have tomatoes and mustard because bees had to pollinate those plants, bumblebees for ketchup and honeybees for mustard. You wouldn't have pickles because pickles come from cucumbers that have to be pollinated, by honeybees. And you're like, well, aha, Jamie, you've got cheese and beef. And I'm like, well, cheese and beef. Yeah, a lot of cattle is grown by feeding them clover and alfalfa. right? And these things are things that bees have to pollinate. So really what you'd have is you'd have bun, some cheese, some meat, and bun. So we know how important honeybees are to us because of their contributions through pollination. And of course, they're important to beekeepers that way as well. I love this graph. In 2011, some USDA scientists put together this graph showing the major the major pollination dependent crops in the United States. You can Google this graph, this chart, and it's a figure. If you can Google this figure, you can see it and use it yourself. And if I were face to face with you, I love doing this critical thinking exercise that almost everybody screws up. So I'm going to answer it for you since this is completely on Zoom. But if you look at this map, I always ask people, and I'll pause for a second. I'll say, what can you look at this map and tell me about honeybees? And so before I do that, I'll go around the country and tell them the different things that honeybees are used to pollinate. Some citrus, cucumbers, melons, blueberries, apples. I'll try not to repeat myself. Cranberries, cherries, plums, sunflowers, canola, some alfalfa, raspberries. I think I've said cranberries, cherries, pears, almonds. And if you're from California watching, I'm talking about almonds, avocados, sunflowers. Yeah, I think that's about it. And so I always ask people, what is it that you can tell about honeybee pollination by looking at this map? And almost everybody says, aha, all of the crops that honeybees are used to pollinate are grown close to the ocean. And then I have to smack my face and remind people that there is in fact a country up here and a country down here. Despite what Americans think, the United States is not an island. So usually what people mean when they say that the crops are grown close to the ocean, what they really mean is the crops are grown on the perimeter of the country. And incidentally, that's why a lot of bees are not taken to the center of the country, because that's where our bread basket is. That's where all of our wind pollinated crops are grown. So honeybees have these migratory routes, thanks to their beekeepers who truck them all around the country, pollinating 4 to 5 different crops a year. And while those bees are sitting on those crops, the growers getting more and better fruits, vegetables, nuts, etc., and the beekeepers are getting money being paid for the pollination services that their bees contribute to those crops. So of course, that's why bees are important, not to mention for ecosystem health, etc. But remember, the title of my talk is What's Killing Bees? So we have to work under an assumption here that bees are in fact dying. And I'm bringing back for you that graph that I showed you earlier, where it shows that NASS in 2020 reports this is what our honey producing colonies have looked like over the years. It's actually rather a terrifying chart if you think about it. Now, I want to kind of restart. I've given you some background on why honeybees are important. I've shown you the alarming charts to show you that bees are dying and we should be concerned. And now what I want to do is I want to break out some data for you on a Thursday night. So Jeff here is from Auburn is one of the individuals in charge of the Bee Informed Partnership Loss Survey. So a lot of these data come from his efforts and other individuals' efforts here on this phone. If you look at the Bee Informed Partnership loss data through 2018, I haven't updated it in the last year, but our winter losses average about 28.2% in the US. Let's just round it up to make it easy for my small brain. Let's say we lose 30% of our colonies every winter. And our summer losses average about 20%. I'm going to round it down a hair just to make it easy to discuss. And the way that these percentages work is they're not additive. So when you factor in all the colonies and all the losses, you end up with about 39% loss. I'm going to round it up to 40. We know survey data tell us that we lose 40% of our colonies every year, right? So the struggle that I have though, and again, this isn't the most updated map, but you know, here on the end, it ticks up the next few years. You've seen that on the previous. But the struggle that I'm having is reconciling, our 40% loss rate with what I'm seeing here. And so what am I seeing here? Well, Varroa were discovered in the US in 1987. And you can figure out the net loss rate since the peak number of colonies we have. We can figure out that prior to the introduction of Varroa in this box here, we net loss about 1% of our colonies a year. So let me explain what that means. If we have 100 colonies, next year we're going to have 99. The following year, we're going to have 98.1. The following year, we're going to have 97 point something, right? We're net losing 1% of our colonies a year. Interestingly enough, after the introduction of Varroa, the loss rate slowed. We now lose 0.5% of our colonies, roughly, every year, net losses. Since 2006, now the reason 2006 is something it's easy for me to remember is that's the year I was hired at the University of Florida. I started in August in 2006. And in November of 2006 is when the beepocalypse happened and we all started starving to death. Remember? So we were all starving to death the last 13 years because honeybees were dying absolutely everywhere. But since 2006, that's roughly right here on the chart, we have averaged a net increase of about 1.2% of our colonies a year. So I probably need to pause and let that sink in just a hair. We're losing 40% of our colonies, but we're recovering, I'm going to round it down again to make it easy, 1% of our colonies every year. We actually start off. So how do these two numbers reconcile? Well, these loss rates that you are actually hearing about are gross losses, not net losses. So if you have 100 colonies, you're going to lose 40. That's the national average. You're going to have 60 at some point in the year. But we are beekeepers. We do something with those 60 to recover the losses that we just had. So what do? We split, we buy packages, etc. We catch swarms. So even with a loss rate of 40 colonies out of 100, we're going to regain 41 colonies and end the year with 101. So our gross loss is 40%, but our net change is actually an increase of 1%. What's interesting is we have more bees now than we've had in the last 25 to 30 years. And that's all with 40% loss rates. So we've kind of got these dueling issues happening simultaneously. We've got these high gross loss rates, but we've actually averaged net increases every year. So again, to make the math simple, we have 100, we lose 40. That's our gross loss rate. We've got 60. But with those 60, we recover 41. So we now have 101. So we've increased 1% over what we started with at the beginning of the year. So we've got these dueling issues. We don't actually have net losses of bees. We have gross losses of bees. And so that raises this point, what is happening to bees? All right. So there's two factors at play here. The things that drive the gross losses are all the stressors that we talk about as beekeepers. The things that drive the net change in numbers is usually money. When pollination and honey prices go up, it's more affordable to recover losses. When they go down, it's less affordable to recover losses. In fact, Dennis Van Ingelsdorp from Maryland a few years ago showed that the peaks and valleys on this chart most correlate with honey prices, not with pathogens. So really, the thing probably most responsible for the actual number of colonies we have in the US is economics. But the things responsible for the gross losses, these 40% losses we're having every year, those are the stressors. And with a title like What's Killing Our Honeybees, I have to work under the assumption that they're actually dying and talk about what the major stressors are. Okay, so before I get there, I just wanted to show you a fun slide that I really like showing in Florida. Again, this is just Florida. It's not indicative of everywhere, but I think it's a really neat slide and it really drives home some important points. Number one, in Florida, we have roughly 4,800 beekeepers. About 4,000 of those, or 84%, are hobbyists. About 235 of those or 5% are sideline beekeepers, and about 520 of those, about 11% are commercial beekeepers. So to make this easy, that, we've got roughly 10% of our beekeepers are commercial beekeepers. If you look over here though, here's the number of colonies managed by those individuals. So 4,000 people in Florida manage 30,000 colonies. 520 people in Florida manage 600,000 colonies. The average hobbyist has 7 colonies. The average commercial beekeeper has over 1,100. The point that I'm trying to make is if you're trying to help a beekeeper, you help hobbyists. But if you're trying to help honeybees, you've got to help commercial beekeepers, because that's where the bees are, right? So one of the interesting things that I think BIP does, in addition to providing the loss rate data for us, is they ask beekeepers, what do you think was most responsible for killing your bees? And I'm going to back up a slide because I don't want to give away my grand finale, as it were. It does not matter where in the world I ask that question. Beekeepers almost always tell me the same thing. Usually at this point in this presentation, I'll say, beekeepers, I want you to tell me, not hearsay, not what the press tells you to say. I want you to think, what is the number one killer of your bees? Not your neighbor's bees, not that commercial beekeepers down the road's bees, but your bees. And when I ask that question and then give people about 10 seconds to think about it and then open the floor, the beekeepers around the world tell me the same things. In fact, they tell me the exact same things that they tell the Bee Informed Partnership. So here's the drum roll, boys and girls. What's killing honeybees? Here's your answer. When you ask beekeepers in the United States what's most responsible for the loss of their bees, they tell you 5 things. And I'm not going to tell them in any particular order because every year it kind of changes a little bit. And don't worry, you're going to get a summary slide, so hang tight. They say mites, and by that they mean varroa. They say queens, and by that they mean queen quality. They say starvation, and by that they mean nutrition. They also say bad weather, and they also say weak in fall. You're going to see that a lot, so don't panic if you didn't get all of those. All right, so varroa, queens, bad weather, weak in fall, and nutrition. Now, early on when BIP was asking these questions to beekeepers, the terminology changed a bit. So to maintain consistency through my talk, I'm going to use those 5 terms, even if they're slightly different terms in the BIP surveys. But just to show you, the first year is the only year that beekeepers listed colony collapse disorder. They listed queens, nutrition, varroa, CCD, and weather. Every other year, CCD was replaced by weak in fall. You don't believe me? Nutrition, queens, weather, varroa, weak in fall. Nutrition, weather, weak in fall, varroa, queens. Nutrition, weak in fall, weather, queens, varroa. Weak in fall, queens, nutrition, varroa, bad weather. Weak in fall, nutrition, queens, varroa, bad weather. And then they switched to bar graphs, which make it very difficult for me to do this quickly, but you'll just have to trust me. Queens, nutrition, varroa, weak in fall, and bad weather. Queens, nutrition, varroa, weak in fall, and bad weather. Queens, nutrition, varroa, weak in fall, and bad weather. And basically, boys and girls, you get 5 things that beekeepers say are their principal issues: varroa, bad weather, weak in fall, queens, and nutrition. So I've put those on this slide for you. A lot of you are beginners and you're being bombarded with, you need to worry about this and you need to worry about that. There are bukus of things that are capable of killing your bees. Bukus of them. But it's most important that you learn how to address the biggest stressors, because those make the biggest impact on the health of your colonies. Now, I've been telling you there's 5 things. And if you'll look on this slide, you'll see that there's 7, in fact, but I'm going to explain why that's the case. First of all, the early surveys just asked about mites. And again, I'm translating that varroa. They didn't necessarily ask about the stuff that Varroa transmits. And really, you can't have Varroa without the pathogens, or those pathogens without the Varroa. A bee with just Varroa but no pathogens has a minor nuisance on its body. The bee with pathogens without the Varroa just has a minor nuisance in its body. The bee with Varroa and the pathogen dies. So I am going to tease those two apart and remind you that they are basically part of the same complex, Varroa. So that explains one of the extras. The other extra I'm going to point out is pesticides. And I'm going to point it out because I'm about to make some people happy or unhappy with these statements. And please be nice to me, because my wife and kids are on the other side of this wall. They're hearing everything and they don't want to read mean, nasty chats. But I have to put pesticides, because if you don't, beekeepers want a pitchfork and come after your house with torches. If you correct for commercial beekeepers, pesticides usually hover around number 6 or number 5. That means commercial beekeepers list them as a major issue. But if you ask the vast majority of beekeepers, including hobbyists and sideliners, they don't list pesticides in the top 5. They are a significant stressor. It's not rocket science. Insecticides kill insects, and bees are insects. The question is, are they a principal enemy of honeybees? Are they a principal cause of colony losses? Are they something that every beekeeper is going to face every year? And the answer is likely no. In my 30 years of keeping bees, I've yet to identify a pesticide problem in my colonies. Now, absolutely, if I were pollinating lots of crops and moving my bees to areas where pesticides were used heavily, they'd play an important role. However, every one of these other things have killed colonies of mine in the past. Before I dive into this further, though, I really want to take two things off of this list. The first thing I'm going to take off this list is week and fall. And the reason I'm taking it off the list is because week and fall is not a stressor. It is the result of these other stressors. So weak and fall didn't kill your bees. Varroa made your bees weak and fall. Nutrition issues made your bees weak and fall, so on. So I'm taking it off because if you remedy these other things, you'll remedy weak and fall. The other thing I'm going to take off is bad weather. Now, I travel the world. In fact, I had to tally it up recently. I have spoken to bee clubs in 37 of the 50 US states. So if you're one of the 13 states who hasn't had me, shame on you. I'm looking forward to visiting you someday. And I've spoken at lots of countries around the world. And every time I go somewhere, people tell me this. When you're kind of making small talk, when you first meet people, I'll say, wow, it's cold here. Man, it's raining a lot here. And people always tell me the same thing. We've got this saying in wherever your hometown is, if you don't like the weather, just wait. And they're basically making a proclamation that their weather changes. It's the most unique weather on planet Earth. Well, everywhere I go has unique weather. Right now, it's thundering and lightning here. It's raining here. We have hurricanes. In California, they have droughts and wildfires. There are places that have tornadoes. Some places it's too cold. Everybody has bad weather. I cannot, in my lab, create a plastic strip that you can hang in your hive and control bad weather. So my point to you is bad weather is going to kill your bees, but you have to manage around it. It's not something you can do to your hive to fix. So I'm taking it off the table, which means in my opinion, there are 3 big stressors of bee colonies. And it's not just my opinion. This is what beekeepers say. Varroa and the things they carry, nutrition, and queen management. And I've added pesticides just to be the kind of lucky stepchild here to discuss. So I am utterly convinced that beekeepers who know how to address Varroa, know how to address nutrition issues, and know how to address queen issues more often than not are going to keep their colonies alive. And then all of these other things that worry us, beetles, pesticides, nosema, tropolalaps, blah, 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 blah. All of those things will seem like minor nuisances if we can address these big issues. And again, pesticides do kill apiaries. They do it every year, but it's not something every beekeeper will have to address. So let's think about this a little bit, and then let me show you some resources that may help you a bit. So we'll start with Varroa first. This is an image of Varroa. Now, you know, it all depends on how you view things in life. I happen to think just about all life is interesting. Varroa is terrible. I started keeping bees when Varroa was already here. It's something I've always had to live with. I don't remember the good old days. We all know that Varroa feed on honeybee fat bodies and partially on the hemolymph. We know that they can transmit diseases. In fact, you see a bee here that's diseased with crinkled, deformed wings. That bee was given that virus while she was developing as a pupa, because that's where Varroa feed. Varroa and the pathogens it carries together, they are the #1 killer of bees on the planet. I believe that with my life, with my heart, with my research, with my colleagues. I believe this is the issue. Now, remember, this talk is what's killing honeybees. And I've just told you what beekeepers say kill honeybees. This isn't me. This is beekeepers. So now we've identified potentially public enemy #1. What can we do about it? So I'm going to stop for just a second. I'm going to share a different screen and I'm going to show you. And Allison, for some reason, if you can't see what my Google page here, if you'll let me know and I'll try to make this better.
We can see.
Perfect. If you guys are watching me do a Google search, I want to show you exactly how to find what I consider the world's best document on Varroa control. And I can say that because I had no part in its development. This is not me trying to sell something that I was involved in producing. If you Google honey bee health, and I'm a world's worst speller, that's why I love Google. It fixes all my problems. And I'm not going to spell it right on purpose, but if you Google Honeybee Health Coalition Varroa and press enter, Honeybee Health Coalition Varroa, and press enter, this link right here, Honeybee Health Coalition Tools for Varroa Management, is the document you need to memorize, read 6 to 15 times a year, and to follow it. So I'm going to click on this link and show you the power of this document. First of all, it starts with the word free. You pay nothing. You pay squat diddly. You can tell I'm from Georgia, can't you? I'm breaking out my sweet Georgia words. Incidentally, you can see me. Go Dogs. But you pay squat diddly for this. And if you click here, you get a free PDF that explains to you how to monitor for Varroa, how to treat for Varroa, how to make decisions related to Varroa control. If you don't like reading, and a lot of the world doesn't, they have made a video for absolutely every part of their document. And what's a shame to me is that they felt it was necessary that the first video that they produced is a video entitled, "Will Varroa Kill My Bees?" Why is that a shame to me? It's a shame to me because we have convinced people over the last 20 years that Varroa is not a problem, so beekeepers don't do enough to stop them. Varroa will kill your bees. They'll kill your bees dead, and you need to address them. And there's videos here that show everything that this PDF shows. If you want to share the story of Varroa and Varroa control with your local bee club, the Honeybee Health Coalition even made a video that you can download and show at your bee club to get your beekeepers on board. They even created a Varroa management decision tool to help you make decisions when is the right time to treat Varroa and how to treat them. So rather than giving you a presentation on Varroa, what I want to tell you is that this resource is fantastic. It is the best resource I have seen ever. And I've looked at lots of other countries' resources. We're fortunate that it's available to us and they update it all the time. And if you read it and commit it to memory and follow its precepts, you will go a long way in addressing your Varroa problems. So what I want to do now is I've told you that Varroa and the pathogens they carry are a big deal. What I want to do now is switch to queen quality. Queen quality is very important. It's funny, when I used to start keeping, when I used to teach people how to keep bees, I would go around to bee clubs and saying, there's really only 2 things you've got to know to make lots of honey. You've got to control your diseases and pests, and you've got to manage your queens. And most hobbyists aren't comfortable managing their queens. What is queen quality, right? So queen quality means, when I was brand new beekeeper, if I had a queen in my hive, I was so happy. It did not matter if she was laying one egg a week. If I saw her, I was happy and I was going to do nothing about it. She was there, I was great. But you know what? Just because she's present doesn't mean she's good. Queens can produce lots of offspring or few offspring. They can confer good genes or bad genes, right? And we have to learn to recognize and remedy queen issues. And I have a colleague from North Carolina, and he described it better than me. He said he uses the word queen events. So anything related to a queen event, the loss of a queen, the failure of a queen, the swarming of a queen, some sort of queen event, something that happens related to queen quality, we've got to learn to spot, to remedy, and to manage it appropriately moving forward. And unfortunately, so to me, here's the deal. The beekeepers said Queen's Varroa and nutrition are their big problems. The Honeybee Health Coalition created a fantastic Varroa document. We now need that same sort of resource for queen quality, because queen quality is the hardest thing to address. And let me explain what I mean before I go to nutrition and kind of wind this down and take some cues and hopefully give you some A's. The reason queen quality is so difficult is it's not a predictive science. Let me give you an example. If you're monitoring for Varroa and you roll 3 Varroa per 100 bees, and if you don't know what rolling 3 Varroa per 100 bees is, go read the Honeybee Health Coalition document. If you roll 3 mites per 100 bees, you can predict that a problem is coming and that it's time to treat, right? But there's no looking at queens and predicting what's going to happen downstream. Well, maybe her brood pattern's solid. Well, Dave Tarpey and colleagues showed that it didn't matter if they had solid patterns or not. That's no predictor of quality of queens. Well, maybe she's laying lots of eggs. That's no predictor of quality queens. You only know if you've have a good queen or not once it's too late. How do you know if your colony is going to produce a lot of honey and you can attribute that to the queen? You have to go through a honey season. So you really only know if your queen's good or bad once the damage is done. So we need better research on predicting queen quality and addressing queen quality. All right, so that's your second big stressor. Your third big stressor, and again, the BIP usually uses the term starvation, and what they really mean by that is that beekeepers are saying their colonies are running out of or don't have access to new carbohydrate resources, usually honey, or in the commercial beekeepers' case, maybe sugar water or corn syrup. And I find that this is a widespread problem with beekeepers. And, the beekeepers say it themselves in surveys. I see it with my own eyes. We just don't trust our instincts with food. When despite maybe the persona that I'm throwing off here for you on this Zoom talk, I'm actually not very much of a people person. I'm very much an introvert. In fact, the Corona shutdown that we've had kind of played into my wife and my strengths. We're just here with our family, and that's kind of been okay with us. And the reason I'm saying that is when I was in Georgia, I produced a lot of honey as a kid, and I had to go sell it at farmers markets, which is not the introvert's thing. Because, people walk by your stand and they kind of give you that weird stare, like, should I go in there because it's a kid? I feel sorry for him. Should I go buy his honey? And all that awkwardness that I had to face through all the years. And I used to brag, oh, Lord, someday if you'll just let me live in a place where I can keep my bees healthy, but they'll produce no honey that I have to get rid of. Well, that, boys and girls, is High Springs, Florida. That's where I live. My bees produce nothing here that is marketable. So people have this idea that you can plant bees everywhere and they're going to have all the carbs that they need, but that's not true. We have to learn to recognize carbohydrate stress in bee colonies and be willing to feed our bees to solve that problem. We have to be willing not to take too much honey from them so that we don't push them into a corner where they have no food. We have to be willing to take the necessary steps to provide the nutritional supplements that bees need. Now, if you look at this photograph, everything here is related to pollen. I'm scared to even bring this up because I usually get boos and hisses when I bring this up. but I've yet to do a research project on pollen substitutes and ever make them improve anything in a honeybee colony. I can't get more bees. I can't get more brood. People keep telling me it's me. They keep telling me it's my experimental design. So I'll change my experiment. We'll do something different and we'll get no result. So I am not convinced that nutritional supplement research is where it needs to be. I think we need a lot more research in addressing the pollen deficiencies that our bees face. It's easy to address the carbohydrate deficiencies. You just feed them sugar water or something like that. But it's much harder to address the pollen deficiencies. And I believe that a lot of research is heading in that direction here in the near future. So I'm not going to beat a dead horse, but I'm going to make some of you happy by discussing this. Yes, pesticides kill bees. They do it every year. We do tons of pesticide research in my lab, and I can give bees a dose of nearly any pesticide you want to show me. I can give a bee enough of that stuff to kill them. You know, a much bigger question is what's the risk associated with a given pesticide in the scenarios that bees are exposed? I would argue that pesticides are probably more like secondary stressors. You've got these big things, queen issues, varroa, nutrition, weather, all of these things, kind of big things attacking colonies. And then you've got these underlying stressors like viruses and pesticides and beetles and wax moths that just exacerbate some of the stress that these bigger things have or do to bees. And I think that that's the role that they play. And we certainly need to do a lot of work to try to figure out how to mitigate these impacts. I would be the first to tell you. But oftentimes, apart from moving bees, it's hard to stay on top of bee exposure to pesticide. I mean, we can reduce what we use in colonies, but it's much harder to reduce what they get exposed to in the wild. And it's simple math. If bees can forage a 3 to 5 mile radius around their hives and the area of a circle, is pi r square, then an area with a 5 mile radius is nearly 80 square miles. And for those of you who work in kilometers, that's nearly 200 kilometers squared. That means a single honeybee colony is foraging an 80 square mile area or a 200 kilometer area. It's hard to control the toxin input in that footprint. And couple that with varroa and beetles and nosema, you've got recipes for issues. But these are things that are much harder for beekeepers to spot and to address when we've got things at our feet like varroa, nutrition, and queens that we can manage. We can address these things. So I'm really winding down. What I want to do here before I go to the last of all the last slides is I want to tell you a few things. Number one, the problems that you're going to have more often than not are going to be weather related, nutrition related, queen related, and varroa related. Don't take my word for it. Take the beekeeper's words for it. That's who said this. Some secondary stressors, nosema, viruses, the foul broods, pesticides, small hive beetles, all of these things. It all depends on how you define stressor. All of these things are issues for bees. But we have great beekeepers keeping bees alive. We have great beekeepers keeping bees alive. We have great scientists doing great research. We have great extension officers giving out good information. We are going to overcome the issues that bees face. We are going to do that. And so as I wind down and get close to taking some questions and answers, I wanted to show you a few things. My lab's website is here. This is a wonderful time for you guys to take a screenshot or perhaps use your smartphone to take a picture of what you see. We have a very active social media account series. We're on Twitter, Instagram, and Facebook. You can find us at UF Honeybee Lab. We have lots, thousands of followers there. So you can go to our website. You can go to our social media accounts and see all the stuff that we're up to. We created a podcast that we began releasing back in January. It's become, oddly enough, wildly popular. It's called Two Bees in a Podcast. Just because I love to show people how to find stuff rather than tell you that it exists, let me share my Google. I'm going to go back to Google, everybody's friends. If you just Google UF Honeybee Lab, just UF for University of Florida, UF Honeybee Lab, and press enter, your top choice will be my lab. And once you get there, you can watch you listen to our podcast. We interview bee scientists and beekeepers from all around the world. You can join our bee colleges. Our virtual bee college is coming up in August. You can join our master beekeeper program, In nearly everything that I taught you today, if you go to the homepage, if you click on Beekeeper Resources, we have tabbed by topic everything that my team and I produce related to these topics. So for example, if it's come out of my lab and it's about honeybee biology, you can find it here. If it's come out of my lab and it's about pesticide impacts on bees, you can find it here. So the lab website, www.ufhoneybee.com, is the gateway to our bee college, our online master beekeeper program, our social media accounts, our blogs, and all the stuff that we have up and going. So what I want to do now is go back to my presentation. I want to say thank you to all of you guys and girls who have been patient and listened to me through all of this. Again, here's your last chance for a screenshot or for a cell phone image before I turn it back over. And thank my sponsors, my colleagues at Auburn and Alabama, University of Georgia, University of Tennessee, Texas A&M, and of course, University of Florida, and others who've been involved to make this possible. You're going to be hearing next in June from one of the colleagues who works with me here at the University of Florida, Dr. Cameron Jacks, going to be talking to you about varroa biology and management, which you now know is one of the big three stressors beekeepers mentioned. So please keep supporting this. And I'm going to stop and try to use the last 12 minutes for some questions and answers. So thank you guys so much for your attention. I look forward to getting some of those questions, Allison.
Dr. Ellis, that was a really good presentation. I really enjoyed it. We do have some questions, and if you have questions, if you want to type them in the chat box, we will try to get to them. So here's a couple that have come in so far. How do you protect your bees from aerial spraying of mosquitoes?
Yeah, so we get that question a lot. I'm going to give you a short answer, but I want you to do me a favor. I want you to Google ED for Douglas, EDIS, EDIS, EDIS. If you Google EDIS, honeybee mosquito, EDIS honeybee mosquito, my team and I have created a document that essentially answers that question in detail. So some recommendations that we make is keep your bee colonies off of the road. We tell people if they know the aerial sprays are coming, you can put a big sheet of plywood over the top of your colony so that it completely envelopes the footprint of the colony so that no compounds can come straight down onto the bees from above. We also give some recommendations for how to contact your local mosquito control district so you can find out when the aerial sprays and the other sprays are happening so that you can prepare your bees. But in that one document, we've got a lot more information related to things that you can do to protect your colonies from exposure to mosquiticides. Great question. Thanks.
Wonderful. I actually had that question come in myself this week. What does research say about the effects of pesticides on weakening both queens in terms of quality and bees in terms of becoming more prone to falling prey to varroa and diseases varroa carry?
Yeah, that's a great question. So, there's the first two questions out of the gate are about pesticides, while I stress the biggest issues were varroa nutrition and queens, which is exactly what I predict. This is what I see at nearly every bee meeting. So to respond to your question is that every stressor in a colony is capable of influencing the impact of another stressor. You could just as easily ask, what's the impact of poor nutrition on varroa susceptibility or on small hive beetles on queen quality? But yeah, pesticides no doubt plays a role. Jeff Williams, who's one of the key scientists here collaborating with this, making it possible, he does a lot of work with pesticide impacts on honeybee reproductives, queens and drones, and he's found potential impacts on queens and drones. We do a lot of work, synergistic impacts of pesticides with other stresses ourselves. Some of the problems I have with pesticide research, and this is just kind of for what it's worth as we wind down, is most pesticide research I see shows what impacts are possible, not necessarily what impacts are likely. And so oftentimes we'll see, a whole range of things that are possible, but not necessarily things that are likely to happen in a field. So a lot of us certainly believe that pesticides can cause stress in colonies and weaken bee ability to fight varroa, viruses, mask as nutrition impacts, et cetera. And those are definitely active areas of research that people are looking into, largely because we believe that there are probably synergistic impacts. That's what synergisms are when bee scientists are talking about it. We certainly believe that the two can play a role.
Another question that has come in, how can I be sure that my queen is a good queen?
So how can you be sure that your queen is a good queen? I always give some basic recommendations for this. Number one, make sure you're getting your queen from reputable queen producers. And how do you know? You ask people in your local bee club, where do they get their queens, and do they like them, right? Word of mouth really helps. There are good queen breeders and less good queen breeders. And so finding that out. Number two, you can look at the basic stuff that's not necessarily fully indicative, but supports the idea that she's good, right? Does she produce lots of offspring? Is her pattern mostly solid, even though that's a questionable impact? And again, does she come from a breeder line that has a long history of productivity? That's the issue with queens. It's hard to predict. So the best thing we can do is stack the deck in our favor before pulling the trigger. And how can we do that? We can make sure that we are purchasing from a tried and true producer who's got a long history of documented good quality queens. But even in those cases, you might get a lemon, right? If you buy 50 LG TVs, 49 are going to survive 5 years. One's going to die in 2 months. So, you go back with the breeder who's consistently given you a high quality product, and just know that every once in a while you might get a lemon because you're working with life. This is life. But that's what I like to do. And incidentally, I've got a document on honeybee stocks on our website under Beekeeper Resources to kind of give an overview of what stocks are available and what are the various traits of these stocks that you might be interested in having in your population of bees.
That's wonderful. This one may get you in trouble. Is there
That's
a
okay.
particular breeder that you like, you would recommend?
Let me tell you how I answer that question. I love that, first of all, by the way. But what I would tell you is that every one of you who is listening to me right now, which is hopefully every one of you, you should all join your local bee club and your state bee club, because that's the kind of question your local peers need to answer. It's all word of mouth. You ask the 50 people in your local bee club, you ask the 30 people in your state. You're asking me specifically, but I'm from the Southeast, so I only know Southeastern breeders. What I tell people is it's important to know what stock you want. Russians, Minnesota hygienic, New World Carniolans, Italian bees, whatever. Know what stock you want. And then I always tell people, once you know the stock, go to the originator of that stock and ask for recommendations for breeders. So for example, if Russian bees are your thing, you'd go to the Baton Rouge Bee Lab in the USDA and say, hey, I like Russian bees. Where should I buy Russian stock? If Minnesota hygienic bees are your thing, you would contact Marla Spivak and say, hey, I like Minnesota hygienic bees. Where should I find some? So if when in doubt, ask your peers. When in doubt, go to the originator of that stock and try to get recommendations from them on who's really maintaining quality stock lines that they had originally envisioned. That was totally a state-sponsored answer, right? That was about as generic as it could be.
You navigated that very well. I'm very, very proud of you. We've got a lot of questions that I'm trying to get to as many as I can here. Here's one. Jamie, do you agree that the best chances of us being able to combat the mite problem is better queen genetics?
So in my unprofessional opinion, queens are an important piece to addressing mites, but it's the piece, in my opinion, that's been neglected too much. That does not mean there's no good breeding programs. There are fantastic breeding programs. When I was a postdoc at Georgia, I did a lot of work with Russian queens and found that you only had to treat this particular line that we were using every other year. They outproduced the treated colonies. They outproduced the unselected colonies. So I'm a firm believer that breeding can get us there. The problem we have in breeding, there's two problems. Problem number one is that a proportionately small percentage of the beekeeper population will actually purchase resistant stock. Most of us will just purchase whatever we can get. Problem number two is if I were a cattle breeder, I can instrumentally inseminate cattle easily, or I can put the bull and the cow in the same fence and I know what's going to happen. But with queens, you can't do that. So people might purchase good breeder stock or good stock, and then they don't realize that the average queen turns over every 6 months to a year. And within 6 months to a year, you've lost that. You've allowed the colony to requeen itself, and you've lost it because your queen is open mated. So the issue that we have is, yes, I agree with you. In my opinion, we could breed solutions to our bees. I firmly believe it. I've seen it with my own eyes. We've just got to work on adoption, and we've got to work on subsequent control. In my opinion, if you commit to a stock of bees, you can't half commit. You can't say, I'm going to requeen with the stock and I'll let them requeen themselves for a couple years and then I'll bring back the stock. It's every year you requeen with the stock from the source, because very quickly you can lose traits. I do believe we have the science to address Varroa through breeding. We just got to get better adoption in the industry.
Okay, we've got a lot of questions about queens coming in, but I do want to get to some others. What are your best recommended resources for nutrition? Is there any research on all the nutrition additives being sold for honeybees?
So there's two questions there. So the nutrition you're asking about specifically, what I want to do is go back a few slides. A few years ago, I say a few years, maybe 15 years ago, Australia produced some scientists in Australia produced a book called Fat Bees, Skinny Bees, and it was a fantastic manual. It was basically the nutrition Bible. You can find it online for free. You Google Fat Bees, Skinny Bees. And, that was 15 years ago. And since then, there's been a lot of additional research on nutrition. So this is a good beginner course on bee nutrition, but you're going to have to attend bee talks. You're going to have to attend state meetings to hear the latest on nutrition. There's a lot of research papers out there that are about nutrition. You just have to be willing to kind of dive down into the weeds. Your second question, is there a lot of information on these nutritional supplements related to keep, bees, these feed supplements? And in my opinion, there's not enough. If someone creates a liquid and puts it in a plastic bottle, they can get people to buy it and put it in their hives. And so I think there needs to be a lot more work on some of these things that people think are good, but we really don't know. To me, we know a lot about feeding sugar water and corn syrup. We know some about pollen patties. We know very little about the additives. So I think the jury's still out on some of those. It's a great question.
All right, one last quick question. Do you have a preference for one type of Varroa testing over another? For example, powdered sugar over alcohol?
Yeah, I do like the powdered sugar shake, and that's only because I don't like to kill bees. I think you get a little bit less accuracy that way, but it's mostly the same. And as the alcohol wash, a lot of commercial beekeepers will alcohol wash. And incidentally, you don't have to do your whole apiary. You usually only have to do about 10% of your apiary. You get a lot. So if you have 30 colonies in an apiary, if you do 10 of them, you're going to get a pretty good indication on if the whole apiary needs treated or not. But I like to do powdered sugar shakes or powdered sugar rolls. You'll find out all about that in the Honeybee Health Coalition document. And you can also watch a video on it, I believe, at the Honeybee Health Coalition website. Thank you guys so much. Let me just tell you on the way out, you can do this. I've been doing it for 30 years with the same stressors that your bees face. You can do this. Ask for help, but please just enjoy it. Keeping bees is fun. Just go have a good time. And I thank you guys for joining me tonight. So Allison, I know you want to wrap it up, but I want to thank everybody for putting in the time to listen.
Thank you very much, Dr. Ellis. That was very informative presentation. I did have a poll up. If you've got a second and you haven't answered it, please answer that poll for us. It really helps us. I want to thank you for your presentation this evening, Dr. Ellis, and I want to thank Drs. Rangel, Williams, and Jack Rowe for their work answering questions. Rusty Priestley helped us with our IT issues, and Donna Shanklin helped us with the Facebook live stream. And we want to thank you, the participants, for being here today. If you want to go back and review all of the good information you learned tonight, you can go to the Lawrence County Extension Office, Lawrence County, Alabama Extension Office Facebook page, and you can find this video for 2 weeks in that video section. You have until tomorrow afternoon to watch Dr. Delaplane's from 2 weeks ago. So if you want to get that one in, go ahead now and do that before tomorrow at noon. You're welcome to review the presentations, but we ask you please don't appropriate any of the slides for any other venues that you may be presenting in. Our next session will be on Thursday, June 11th, and we've got another University of Florida speaker. Dr. Cameron Jack will be here to tell us about Varroa biology and management, and we really hope that you all will join us for that. Thanks, everyone. Have a good night and stay safe, and we'll see you next time. Bye.
So Allison, it was